Hi. So this is the third question from quantum mechanics chapter. Which of the following wave functions cannot be solution of Schrödinger's equation for all values of x? Why not? So here we have to check the wave function for all values of x. So that means x runs from minus infinity to plus infinity. So this is the interval, and these 3 points are very important, and this is for well behaved function. The wave function which follows these 3 characteristics, then only the wave function will have a physical significance, and the wave function can be a solution of Schrödinger's equation. So here we have to check these 3 characteristics. So let us start with A. So we have psi is equal to A sec x. So this can be written as A into, so sec x is 1 by cos x, right? So let us check the continuity. Okay, so for x is equal to, let us write, for x is equal to 0, we will have cos x is equal to 1. For x is equal to pi by 2, cos x is 0. So we have 1 by x, 1 by cos x. So 1 by cos pi by 2 will be 1 by 0. So that becomes infinity, right? So let us try to draw a wave here. So that is for sec x. Okay, so 0, pi by 2, pi, 3 pi by 2, and 2 pi, so and so on. So let us try to draw some region. Okay, so we can draw from minus infinity to plus infinity. So let us check it. So the wave starts from 1. So let us say this is 1 and this is minus 1. So remember, the sec x will not start from 0. Okay, so at pi by 2, sec x is tends to infinity, and here at cos pi, the value of cos pi is minus 1. So sec x will have a negative 1. So it start from here, and at pi by 2 it goes to infinity. Again at 3 pi by 2, cos 3 pi by 2 is 0, and it again goes to infinity. Okay, so here it clearly shows that in this region the wave function is discontinuous. The given wave function is discontinuous. Hence it cannot be a solution of Schrödinger equation. Okay, so let us check B. So B is psi is equal to A tan x. So tan x can be written as sin x divided by cos x, right? Again the function goes to infinity at x is equal to pi by 2, 3 pi by 2, 5 pi by 2, right? Because cos of pi by 2 is 0, cos of 3 pi by 2 is 0, cos of 5 pi by 2 is 0, and so on. So 1 by 0 becomes infinity. So that's why the wave function is discontinuous at pi by 2, 3 pi by 2, and pi by 2. In general, we can say the wave function is discontinuous at x is equal to n plus 1 pi by 2. So for all n is equal to 0, 1, 2, 3 and so on. Okay. So psi is equal to a tan x. So these wave functions cannot be a solution of Schrödinger's equation because it is a discontinuous function for all values of x. Now the third wave function, that is psi is equal to a into e to the power x square. So let us check a normalizable condition. So from here we can say, as x tends to plus or minus infinity, the wave function should be equal to 0. So this is the normalizable condition. The function should follow this rule. Then only we can say the wave function is a solution of Schrödinger's equation. So let us check here. So when x tends to infinity, so let us say positive infinity, so the wave function psi is equal to a into e to the power, so x is infinity the square. So we can written as e to the power infinity. So e to the power infinity is tending to infinity. So when x tends to negative infinity, then psi is equal to a into e to the power negative infinity the whole square. So it is equal to a into, so negative of square becomes positive, so we get e to the power infinity. So this will also tends to infinity. So here what is happening? So as x tends to infinity, the wave function is also tending to infinity. That's why the wave function psi cannot be normalizable. Hence, this wave function cannot be solutions of Schrödinger equation. So the last wave function, that is psi is equal to a to the power minus x square. Again we can check the normalizable condition here. So it is a Gaussian, and when say x tends to infinity, the positive infinity, then the wave function psi is equal to a into e to the power negative of, so I am replacing x by positive infinity square. So this is equal to a into e to the power negative infinity the square, or we can write a into e to the power negative infinity. So e to the power negative infinity is equal to 0, right? Similarly, when x tends to negative infinity, we can write the wave function psi is equal to a into e to the power negative of negative infinity to square. So this can be written as a into e to the power negative into infinity square. So a into e to the power negative infinity. So this is also equal to 0. So here, as x tends to plus or minus infinity, the psi is equal to 0. So the psi can be normalizable. Okay. So this wave function is a solution of Schrödinger equation. Solutions of Schrödinger's equation. Hope this concept clear to you. Let me know if you have any doubts. Bye bye for now. Thank you.